Uh, Flux density is quantified in terms of, that is the option A, Weber meter, B, Weber, option C, Weber meter square, and D, Weber per meter square. So option D is the correct answer, Weber per meter square. Consider a coil rotating at a speed of n rpm in the field of p poles. As the coil moves past successive north and south poles, one complete cycle is generated. What is the frequency of the generated voltage? That is the option B, Pn by 120. Okay. A synchronous motor runs at 600 rpm. Which of the following case is true? That is the option A, P equal to 12, F is equal to 50 Hz, and P is equal to 8, F equal to 50 Hz, P equal to 12, F equal to 60 Hz, and P equal to 10, F equal to 60 Hz. Here the answer is option C, P is equal to 12 and F equal to 60 Hz. ठीक है. ओके. नेक्स्ट यहाँ पर जो फॉर्मूला है वही पुराना वाला फॉर्मूला. A works on the principle of the dynamic induced EMF. That is a generator works on the principle of dynamically induced EMF. Next, lower efficiency, lower power factor are the features of the which of the following motors? That is the single phase induction motor, DC shunt motor, three phase synchronous motor, three phase induction motor. Option A, that is the correct answer. Single phase induction motor is the correct answer. Magnetic flux through any closed surface is 1, B infinity, and C 0, and D negative. That is the correct option is the option C, 0. Magnetic flux through any closed surface is 0. Option C is the right answer. Next, what will be the magnitude of induced EMF in voltage in a coil of area of 100 square centimeters with 200 turns if the coil is removed from a magnetic field of 10T acting at right angles on the coil in 1 second? So what is the right answer? That is the, so A is equal to 100 centimeter square, A is equal to 200, and dV is equal to 10, and dt is equal to 1 second. So we have the formula EMF is equal to N into d phi by dt, so that N into dBA by dt, so that the 20 volt is the right answer. And next आते हैं, who invented the alternating current? A, Tesla. Next आते हैं, which one of the following is the correct value of the magnetic permeability in free phase? That is the option C, 4 pi into 10 to the minus 7 is the correct answer. If the magnetic susceptibility of any material is less than 0, then the material is option C, that is the diamagnetic. And next, determine the value of the produced MMF in ampere turns in a coil if the coil has 120 turns and carrying a current of 0.1 ampere. So option A is the right answer. Here N is equal to 120, I is equal to 0.1 ampere, MMF is equal to, so N into I, that is the 120 into 0.1 is equal to 12 ampere turn. Next, determine the magnitude of EMF in voltage induced between the axis of rotation and the rim of the disc when the disc of the radius 10 cm rotates with an angular velocity of 10 revolution per second and placed in a magnetic field of 3T acting parallel to the rotation of the disc. That is the, so formula है B is equal to 3T, A is equal to pi r square equal to 100 pi centimeter square, and next N is equal to 60. So we have EMF is equal to d by dt of BA, that is the 3 pi into 100 into 10 to the power minus 4 into 60 is equal to 5.65 volt is the right answer. So option D is the right answer. Next आते हैं, determine the maximum flux density in T of a material having eddy current coefficient of 2, thickness of 4 mm, volume of 20 meter cube dot meter, and which is supplied by a frequency of 50 Hz when the material has eddy current loss of 6 watt. So P is equal to 6 watt, K is equal to 2, F is equal to 50 Hz, V is equal to 20, and T is equal to 4 mm. So we have the formula that is the P equal to K into B square into F square into T square V. So putting the values and we get Bm is equal to root of 3.75. So Bm is equal to 1.94 is the correct answer. Next आते हैं, in large machine flat copper strip known as windings, risers, brushes and either of these. Option C, that is called the risers, is the right answer. Next, lap winding is preferred for C, high current and low voltage, and we have to know that there is the wave winding is preferred for the low current and high voltage. Which of the following expression satisfies the Ampere's critical circuital law, that is the 48A? Summation of BDL equal to mu 0 summation I. Integral BDL equal to mu 0 summation I. The ratio of the total flux linkage to used flux is known as, that is the option B, flux leakage factor. Next, what will be the permanence in Henry of a coil when the flux through the coil is 50 Weber and the value of the produced mmf is 25 ampere turns? So we know that permanence equal to flux through coil by produced mmf. So 50 by 25 is equal to 2. So option D is the right answer. Determine the magnetic field strength in ampere turns meter when the intensity of the magnetization of the material is 0.078 ampere turns per meter and the magnetic susceptibility of a material is 0.0013. So we know that magnetic field strength equal to intensity of the magnetization by susceptibility, that is the 0.078 by 0.0013 equal to 60 is the right answer. So option A is the right answer. Next, determine the eddy current loss in a watt in a material having eddy current coefficient of 1, thickness of 0.04 meter and volume of 2 cubic meter, which is kept in a magnetic field having maximum flux density of 4T supplied by a frequency of 50 Hz. So this is a numerical problem and we have K is equal to 1, B is equal to 40, F equal to 50 Hz, T is equal to 0.04 meter, V is equal to 2 meter cube. We know that P is equal to K B square F square T square V, and we put the value and we get 120 watt. So option B is the right answer. Next, a consideration of the power losses in electrical machines is essential for which of the following reasons? Option D, all options are correct. There is the operation cost, temperature rise and voltage drop. All are happen in electrical. And permanent magnet excitation is also known as option C, separate excitation. Okay. Next question, the relative permeability of diamagnetic materials. Option C, less than 1. Determine the intensity of the magnetization in ampere per meter of a magnet when it has a pole strength of 60 ampere meter and a pole area, that is the 20 meter square. So we know that that is the intensity of magnetization equal to pole strength by pole area equal to 60 by 20 equal to 3 is the right answer. Next, what will be the magnitude of induced EMF in volt in a coil that has 200 square loops, each of side 5 semi, and placed normal to a magnetic field? The magnetic field increases at the rate of 4 Weber per meter square. So we have N is equal to 200, B equal to 40 Weber per meter square, and area is equal to 5 into 5 centimeter square, and we know that is the phi is equal to B into A. So E is equal to N d phi by dt. So N into dV by dt into A, we put the value and we get 2 volt is the right answer. So option B is the right answer. Next, determine the magnitude of the EMF in volt induced between the axis of rotation and the rim of the disc when the disc of diameter 40 semi rotates with an angular velocity of 40 revolutions per second and place in a magnetic field of 1t acting parallel to the rotation of the disk. So we know that speed of rotating disk equal to half into b into r square into omega, that is the omega equal to 2 pi n, that is the angular velocity, and 2 into phi n, so 2 into 3.14 into 40, so we get that 251.2, and here the magnetic field or B is equal to 1t and radius equal to 20 centimeter. 20 centimeter means 0.2 meter. Applying the formula, that is the epsilon equal to half omega into B into r square, and we put the value and we get the answer 5.024. That is the way, that is the option D, 5 is the right answer. Next, during plugging, external resistance is also introduced into a circuit to limit the following. Option A is the current is the right answer. The parts of the armature electric circuit which take active part in EMF generation are: option A, the coil side inside the slots is the right answer. Option A is the right answer. Next, maximum efficiency will occur when copper loss and iron loss are, option D, equal. Okay. Next question, which of the following of the correct expression for the eddy current loss occurring in a material? That is the option A, K into Bm square into F square into T square into V. This is the right answer, option A. Next, what will be the intensity of magnetization in ampere per meter of a magnet when the pole strength of the magnet is 50 ampere meter and the pole area of the magnet is 0.5 meter square? Here the options are A equal to 40, B equal to 60, C equal to 100 and the D is equal to 120. So we know that intensity of magnetization equal to pole strength by pole area. So 50 by 0.5 equal to 100. What will be the value of magnetic field intensity in ampere turns per meter of a 4 meter long coil when the coil has 220 turns and carrying a current of the 0.4 ampere? That is the, we know that H equal to Ni by L, so 220 into 0.4 by 4, so 22 ampere turn per meter is the right answer. Next, determine the value of self inductance in millihenry of a 6 cm long air core solenoid if the coil has 240 turns and the diameter of the coil is 4 cm. We know that L equal to mu 0 into n square into A by small l. So we put the value and we get the answer 1.514 millihenry. Okay. Next, what will be the value of the magnetic field in MT at the center of the 8 meter long coil when the coil has 260 turns and carrying a current of 4 ampere? We know that N is equal to 260, current is equal to 4 ampere and length is equal to 8 meter. So A is equal to Ni by L, so 260 into 4 by 8 equal to 130. Okay, and B is equal to mu 0 into H, so that 4 pi into 10 to the power minus 7 into 130 equal to 0.163 mt. Okay. Next, no load rotational losses in electric machine consist of: option D, no load core, friction and windage losses. The function of starter in electric motor is starting purpose, avoid the overload, minimize high starting current. All option are correct. Option D, that is the all option are correct. If the area of cross section is reduced to half of its original value, then what will happen to the flux density? Option A, doubled is the right answer. Option A, doubled. Calculate the value of the flux leakage coefficient if phi G is the air gap flux and phi A is the flux of the iron core. Option B, phi a by phi g is the right answer. Next, a conductor of length 0.6 meter is situated at the right angle to a uniform magnetic field of flux density 4 Weber per meter square. The conductor is moving with a velocity of 50 meter per second. Calculate the EMF induced in the conductor. That is the option A 100, B 115, C 118 and D 120. We know that B is equal to 4 Weber per meter square, L equal to 0.6 meter and V is equal to 50 meter second. So we have E is equal to B into L into V. So 4 into 0.6 into 50, that is the 120 volt. And next, a flux of 2 meter Weber passes through a strip of length and breadth 10 semi and 20 semi respectively. It is placed at an angle of 30 degrees to the direction of uniform magnetic field. What is the magnetic flux density in T? So we have phi is equal to 2 meter Weber, A is equal to 0.1 into 0.2 and theta is equal to 30 degree, phi is equal to B A cos theta. We know that. So that therefore 2 into 10 to the minus 3 is equal to B into 0.1 into 0.2 into cos 30 degree. So we have that B is equal to 0.1154 T. So option B is the right answer. Next, for the figure shown below, permeability in the core of the 4 into 10 to the minus 4 ampere turn. What is the value of the? Is the option B 0.382 is the right answer. Next, which of the given losses are directly proportional to the square of speed? Option C, windage losses and eddy current losses. Next, which of the following is the correct expression of the Biot-Savart law? That is the option C, dB directly proportional to the ideal sin theta by r square. Which one of the following statement is true about the magnetic lines of the force? So that the option number D, two magnetic lines of force do not cut each other. Option number D is the right answer. Which one of the following material is considered as a non-magnetic material? Option A, diamagnetic material. Option A is the right answer. On which of the following parameters the eddy current loss occurring in a material does not depend? Option C, susceptibility is the right answer. Next, determine the magnetic field strength in ampere per meter of the material when the intensity of the magnetization of the material is 0.084 ampere per meter and the magnetic susceptibility of the material 0.0012. So we know that the magnetic susceptibility equal to I by H. Therefore 0.0012 is equal to 0.084 divided by H. So we have that H is equal to 70 ampere per meter. Next, determine the eddy current loss in what? In a material having eddy current coefficient of 1, thickness of 0.03 meter, volume of the 2 cubic meter, which is kept in a magnetic field of the maximum flux density of 3T and supplied by a frequency of the 50 Hz. So this is also a numerical. So we know that W equal to K into B square into F square into T square into V. So we put that value, that is the W equal to 1 into 3 square into 50 square into 0.03 whole square into 2 equal to 40.5 watt. Next one, the maximum voltage induced in the coil is 200 volt and the rotation angle of the coil is 45 degrees with respect to the coil. Find the instantaneous value of the sinusoidal waveform produced. So we know that V is equal to Vm sin omega t, that is Vm equal to maximum value of the voltage, that is the 200 volt, and omega t equal to 45 degree. So that is the 200 sin 45 degree is the right answer. So option A is the right answer. Next, calculate the force experienced by the conductor with L equal to 0.5 meter and B equal to 4 Weber per meter square when the armature current is 5 ampere. So F is equal to BIL, we know that. So 4 into 5 into 0.5, that is the 10 Newton is the right answer. Next आते हैं, option B is the right answer. Force on a conductor is A, unidirectional. Option A is the right answer. The electric flux field intensity inside a conducting sphere is option A, that is the 0. Enclosure of motor is made from option C, that is the cast iron. Okay. Next, which of the following is a diamagnetic material? That is the option C, lead is the right answer. Which of the following materials shows the paramagnetism? That is the option C, titanium is the right answer. Which of the following is the correct expression for the Gauss law? That is the option A, phi E is equal to Q by epsilon 0. Next, determine the intensity of magnetization in ampere per meter of a magnet when its pole strength is 100 Weber and has a pole area of the 70 meter square. So that we know that intensity of magnetization equal to pole strength by pole area, that is the 100 by 70 equal to 1.43. That is the option D is the right answer. Next, hysteresis loss occurring in a material does not depend on which of the following parameter? Option D, reactivity. Okay. Option D is the right answer, reactivity. Next, determine the eddy current loss in watt in a material having eddy current coefficient of 1, thickness of the 0.02 meter and volume of the 1 cubic meter, which is kept in a magnetic field, flux density 2T and supplied by a frequency 50 Hz. So here we know that W equal to K into B square into F square into T square into V, that is the 4 watt is the right answer. Okay, option C is the right answer. Next, determine the peak value of the current used by a motor rated 220 volt 30 ampere. So we know that I is equal to IRMS into root 2, that is the 30 into root 2, that is the 42.4. Option C is the right answer. Option C, 42.4. The maximum allowable voltage between adjacent segment. Option D, 30 to 40 volt. Next, when the phase sequence of supply current are reversed, the direction of the rotation of the resultant magnetic field wave. Option C, reversed. Okay. Next, what will happen to magnetic flux density produced in a material if the magnetizing force is increased? Option A, increase is the right answer. A magnetic circuit mainly consists of the material having dash permeability. Option A, high permeability. On which of the given factors does the reluctance of the magnetic circuit depend? Option D, all are the options. There is the length, area and the nature of material. Okay. Next, what type of EMF is induced in AC or the DC generator? Option B, that is the dynamic is the right answer. Next, out of the 4 materials ABCD, which will have the lowest retentivity? Here the option is D. Next, the current in the circuit shown is the 4 ampere and calculate the magnetic field intensity in the core if the winding has 50 turns. Here we know that H is equal to mmf by mil length, so Ni by L. So H is equal to 50 into 4 by 2 into 15 plus 4, that is the 200 by 30, 200 by 38, that is the 526 ampere turn per meter. Oh, here is the, that is the 19 into 2, that is the 38 centimeter. Okay, so divide by ampere turn per meter. 526 is the right answer. That is the option C. I square losses or ohmic losses are also known as option A, that is the copper loss. नेक्स्ट आते हैं द काउंटर ईएमएफ ऑफ ए डीसी मोटर, that is the option C, helps in energy conversion. Option C is the right answer. The current flowing through armature conductor of DC motor is AC. If the applied voltage to a DC machine is 230 volt, then the back EMF for maximum power developed is. Options are 115, 200, 230 and 460. We know that EB is equal to V by 2, that is the 230 by 2, so that 115 volt. Okay. Next, compensating winding in a DC machine is placed. Option A, on yoke in the pole faces. The teeth in the armature of a DC machine are sometimes skewed. This is done to reduce, that is the vibration. Option D is the right answer. In a DC machine, fractional pitch winding employed to, option D, both B and C, reduce sparking and save copper. Next आते हैं, in a DC machine without interpoles to have good commutation, the brush shift must be, option C, varied with change in load. The mechanical power developed by the armature of a DC motor is equal to, option A, armature current multiplied by back EMF. The DC motor starter handle should be moved, option B, smoothly in steps. A DC shunt motor may have rising speed torque characteristic due to C, very high demagnetizing armature reaction. Option C is the right answer. Next, DC shunt motors are used for driving. Option D, all of these: machine tools, lathes and centrifugal pumps. The EV by B ratio of a DC motor is an indication of its efficiency. Option A is the right answer. The electric braking system commonly employed in rolling mills, elevators and printing presses is A, plugging. Okay. Next, the running speed of a DC series motor is basically determined by, option B, load is the right answer. Next, the rated speed of given DC shunt motor is 1050 rpm. To run this machine at 1200 rpm, the following speed control scheme will be used. Option B, field resistance control is used. Okay. Next, when the torque of a DC series motor is tripled, the power approximately increased by, option C, 75%, because here the tripled. Which of the following windings are necessary in case of the all machines? That is the closed winding. Option A is the right answer, closed winding. DC machine winding are A, full pitched. Option A, full pitched is the right answer. DC machines are generally designed for maximum efficiency around, option A, full load is the right answer. Option A, full load is the right answer. Next, the armature of DC motor is laminated to reduce eddy current loss. Option B is the right answer, to reduce eddy current loss. If condition for maximum power for a DC motor are established, the efficiency of the motor will be, option D, that is the less than 50%. DC motor with self-loading properties is, option D, differentially compound motor. A large shunt motor should have started preferably using, option A, using a compensator. Which of the following tests can be conducted on other than shunt machines? That is the option B, that is the field test is the right answer. For which types of the DC motor dynamic braking is generally used? Option D, all of the above: compound motor, series motor, and the shunt motor. So option D, all of the above, is the right answer. Next, in DC motor, under leading pole tips, flux density will, option A, increase. Option A is the right answer, increase. If the series field of a cumulatively compounded DC motor is short circuited, then the speed will be, option B, more than full load speed. Okay, option B is the right answer. For DC shunt motor, the field excitation is kept at maximum value during starting to reduce armature heating. Next question, the DC motor that draws almost same power at different loads is, that is the option C, series. In case of DC compound motor is started with an open series field, the motor will, option B, not start at all. The speed of cumulatively compound DC motor can be controlled by varying armature voltage, armature resistance, and shunt field resistance. Any of the above. Option D is the right answer. Next, in Swinman's test of determination of efficiency of DC shunt machine, the no load input power supplies, option A, armature and shunt field copper losses, option B, iron losses, option C, friction and windage losses, and option D, all of the above. So here option D is the right answer, all of the above. In a DC compound motor, the series field in comparison to the shunt field will have, option C, less turns of thick wire. Option C is the right answer. Next, shunt field winding of a DC machine consists of, option A, many turns of thin wire. Option A is the right answer, many turns of thin wire. The armature current drawn by DC motor is proportional to, option A, the torque required, is the right answer. The torque required is the right answer. Compensating winding is provided in a DC motor, option C, to prevent commutator flash over upon sudden change in load. Option C is the right answer. In DC motor, under trailing pole tips, flux density will decreases. Option B is the right answer. The current drawn by 240 volt DC motor of armature resistance 0.5 ohm, back EMF of the 220 volt will be, that is the option D, that is the 40 ampere is the right answer. So we know that is the, for DC shunt generator, EB is equal to V plus IARA, and for DC shunt motor, EB is equal to V minus IARA, so that 220 equal to 240 minus IA into 0.5, so that IA is equal to 40 ampere is the right answer. Next, next, the compound motor has two fields. A 4-point starter is essential for a, option A, compound motor with speed control above normal, that is the option A is the right answer. In dynamic braking, the stator terminal are switched over to DC source from the AC supply, so that the option A is the correct answer. The stator terminals are switched over to DC source from the AC supply. Next, a DC motor develops a torque of 200 Newton meter at 25 rps. At 20 rps, it will develop a torque of what? This is the numerical question. We know that T1 by T2 equal to N2 by N1, because torque of DC motor inversely proportional to its speed, so that T2 equal to T1 N1 by N2, that is the 200 into 25 by 20, so that the 250 Newton meter is the right answer. Next, the shaft torque can be calculated by the formula, option B, 735.5 into bhp by 2 pi n is the right answer. Next, what is necessity of copper brushes in a DC motor? Option D, none of this. Armature reaction effect is more in which of the following method? Option A, field weakening method is the right answer. What will happen in the back EMF of a DC motor vanishes suddenly? That is the option C, the armature may burn. Okay, the armature may burn, option C is the right answer. Next, speed of DC shunt motor has to be controlled through the field. In such case, the most suitable starter will be option D, that is the 4-point starter. 4-point starter. A differentially compound DC motor has its speed load characteristics same as that of the option D, none of these above. And the speed of DC series motor can be controlled by the option A, field diverter. While varying the speed of a DC shunt motor through the field control method, we get option B, 15 to 30% above normal speed. Option B is the right answer. Okay. Next, a DC motor still in industrial applications because it, option B, provides fine speed control. Provides fine speed control. Option B is the right answer. Next, the EMF in DC motor, the EMF in the back EMF in a DC motor, that is the option D, opposes the applied voltage. Next, the most commonly only method of speed control of DC motor is by varying, option C, field strength. A DC motor starts with a jerk while starting the motor, with reason may be, option C, pitted started contact terminals. Next, in a cumulative compound DC motor, when the load increases, option B, speed decreases. Okay. Next, the voltage equation for a long shunt compound motor is given by, option B, V is equal to EB plus IA into RA plus RSC. Okay. Next, the type of motor used in elevators, option D, DC compound motor. If a DC series motor is operated on AC supply, it will show, option D, spark excessively, poor power factor, poor efficiency. Option D is the right answer. Two DC series motors connected in series are driving mechanical load if the motors are connected in parallel to drive the same load. Option C, slightly more than double. Okay. Two identical lossless series motors connected in series across a DC supply voltage run at speeds if N1 and N2. The ratio of the output will be, option B, N1 is to N2. Option B is the right answer. Armature reaction is attributed to, option A, the effect of magnetic field set up by armature current. Next, the armature resistance and brush voltage drop of a 120 volt DC shunt motor are 0.2 ohm and 2 volt. The current at the instant of the starting equals. This is the numerical question. We know that is the armature resistance equal to 0.2 ohm, brush voltage drop 2 volt, and we know that VA is equal to I into RA plus RB, so that here RB is much smaller compared to RA, so we can neglect RB, that is the 120 by 0.2 equal to 600 ampere is the right answer. Next, a DC series motor is accidentally connected to a single phase AC supply. The torque produced will be pulsating and unidirectional. Option D is the right answer, pulsating and unidirectional. How many parallel paths are formed in DC motor? 4-point starters. Option C, 3 is the right answer. What are slot wedges in a DC machine made of? Option C, fiber is the right answer. Next, what is the useful flux per pole on no load of a 250 volt 6-pole shunt motor having a wave connected armature winding with 110 turns? Armature resistance of 0.2 ohm, armature current 13.3 ampere and no load speed of 908 rpm. This is a numerical question. So we know that V is equal to EB plus IARA. So EB is equal to V minus IARA. That is the, we put the value 250 minus 13.3 into 0.2. So we get that EB is equal to 247.34 volt. We also know that EB is equal to 5Z NP by 60A. Okay. So we put the values and get phi is equal to 0.0247 Weber. So that phi is equal to 24.8 milli Weber. Is the right answer. Which of the following is not a method for controlling speed of DC series motor? Here the option C, yoke control, is the right answer. आज के लिए इतना ही.